Hello. In this video, I'd like to talk about signal flow graphs for use with microwave and RF design, particularly S parameters. Flow graphs are useful for analyzing cascaded components because you can graphically represent the network and then apply specific rules to reduce the network and come up with an equivalent input and output cascaded formula for the overall network without having to do a lot of algebra. So it's kind of a graphical technique for analyzing cascaded components, and it can be used with S parameters. And the problem that I've had working with flow graphs or trying to learn about them is that you're at once trying to learn about the concept of how to build the flow graph from a given S parameter block, and at the same time they're introducing new terms, vocabulary terms that apply to the flow graphs, such as nodes and branches. And so it's often hard when you're reading the material, articles about flow graphs, to put the two together. And I'd like to share with you some insight that I've gained after looking at this for some time. So if we start with our typical S parameters, and let me just draw a typical S parameter 2-port block here. We've got our block, and then we'll have a couple of inputs, a port 1 and port 2, coming off each side, sort of squiggly lines here. So there'll be S parameters, and then an input and an output port. And you recall that S parameters are defined by an input and an output wave at each port. So there'll be like an A wave at port 1 going into the port, and a B wave coming out of the port. And the same at port 2, there'll be an A wave associated with it, and a B wave coming out of port 2. Often when you're reading about these flow graphs, you'll see that the ports get drawn in a slightly more abstract fashion, where there's just, instead of explicitly showing the signal and ground terminals, they'll represent the port as a single wire coming out of each side. And you'll still have your A wave and B wave on each side. And let's draw, in this case, the S parameters individually. So we've got S11, S21, S12, and S22 for our S parameters. And so sort of the one observation I've made that really helped me understand how to develop flow graphs, and hopefully it'll help you as well, is in developing the flow graph representation, basically the waves or arrows become dots. And a lot of times when you make statements like this, do the dots become arrows? Well, we don't exactly have dots, but what become the arrows in the flow graph are the parameters. So the parameters become arrows. So let's see how that works. If we take this 2-port S parameter device and make it into a flow graph. So what we've got is on the input, we've got our A and B waves and their arrows. So those are going to become nodes or dots in our flow graph. So the A1 arrow becomes a node, and the B1 arrow also becomes a node. And then similarly on the output, the A2 and B2 arrows will become nodes on our flow graph. Now I reversed the A and B on the port 2. That just is going to help keep things straight. It doesn't matter if you write them in the opposite order, but what we'll see when we start to fill this in is it'll avoid having a bunch of crossed lines. So it still works the same way, it just turns out a little bit neater. Okay, so now let's see how the different parameters become involved here. So going back to the port 1, if we look at the components of the B1 wave, the factors that could add up to the B1 wave, we could see that it's possibly one component is the reflection coming off of the input from the A1 wave. And the factor or parameter that's going to affect the magnitude of that reflected wave in terms of S parameters is S11. So in the flow graph sense, we have the A1 wave coming back out, adding as a component to the B1 wave. And there's also a sort of a convention to draw the arrow in the middle. And the magnitude of that is going to be affected by S11. You could also have a wave coming from the output port, A2, going into port 2 and going through the device and coming out of port 1. So from A2, we could have a signal going to B1. And its magnitude is going to be determined by S12. So those are sort of the waves at the coming out of port 1. Now let's do the same thing for port 2. So on port 2, coming out of the wave at B2, we have possibly the reflection of the A2 wave, and that factor is going to be S22. So A2 will come out as a B2 wave. And similarly, the signal traveling through the device, coming out at port 2, is going to be affected by S21. And what we've ended up with then is a signal flow graph representation of a 2-port S-parameter device. What we'll look at next is cascading a couple of 2-port S-parameter devices, and maybe we'll also throw in a 1-port device. A 1-port device is quite simple because you just have the reflection. But we'll look at cascading these in the next video, and after that, we'll look at some rules to reduce that cascaded network into a single component that can be analyzed, basically using graphical techniques. So I hope you enjoyed this much. Look for upcoming videos, like I said, cascading these components now and moving on.